Article 20 in the National Electrical Code, specifically the 2005 edition, addresses general wiring methods. Within this framework, the concept of ensuring electrical safety through proper connections between premises wiring and the supply system is paramount. The statement premises wiring must not be electrically connected to a supply system unless the supply system contains, for any grounded neutral conductor of the interior, a corresponding conductor that is ungrounded is true. This principle underscores the importance of maintaining a clear and distinct separation between grounded and ungrounded conductors to prevent hazardous conditions. To elaborate on this, let's consider the fundamental purpose of grounding in electrical systems. Grounding serves as a protective measure by providing a low impedance path for fault currents to return to the source. This low impedance path facilitates the rapid operation of overcurrent protective devices such as circuit breakers or fuses, thereby interrupting the flow of electricity during a fault condition and minimizing the risk of electrical shock or fire. The grounded conductor, typically referred to as the neutral, is intentionally connected to earth at the service entrance and at the source of separately derived systems. This connection establishes a reference point at or near 0 volts potential, which is essential for the proper functioning of the electrical system and the safety of personnel. Conversely, ungrounded conductors, often called hot or live wires, carry the electrical current from the source to the load. These conductors are insulated to prevent unintentional contact with grounded surfaces or other conductive materials. The potential difference between the ungrounded conductors and the grounded conductor is the voltage that drives the electrical current through the circuit. Maintaining a clear distinction between grounded and ungrounded conductors is crucial to prevent short circuits, ground faults, and other electrical hazards. The National Electrical Code sets forth specific requirements for the identification, installation, and use of grounded and ungrounded conductors. These requirements are designed to ensure that electrical systems are installed and operated in a safe and reliable manner. For example, the code specifies the color coding of conductors to readily identify grounded and ungrounded wires. Typically, the grounded conductor is identified by a white or gray insulation, while ungrounded conductors are identified by other colors such as black, red, or blue. The statement emphasizes the necessity of a corresponding ungrounded conductor in the supply system for any grounded neutral conductor in the interior wiring. This ensures that the grounded neutral conductor in the premises wiring has a corresponding ungrounded conductor in the supply system to complete the circuit and provide a path for current flow. Without this corresponding ungrounded conductor, the grounded neutral conductor would not be able to effectively carry fault currents back to the source, and the overcurrent protective devices might not operate as intended. Consider a scenario where the premises wiring is connected to a supply system that does not have a corresponding ungrounded conductor for the grounded neutral conductor. In this situation, if a fault occurs in the premises wiring, the fault current may not have a clear path back to the source. This could result in a buildup of voltage on grounded surfaces, increasing the risk of electrical shock. Additionally, the overcurrent protective devices may not operate quickly enough to interrupt the fault current, leading to overheating, arcing, and potentially a fire. To prevent these hazards, the National Electrical Code requires that the supply system have a corresponding ungrounded conductor for the grounded neutral conductor of the interior wiring. This requirement ensures that fault currents have a clear path back to the source and that the overcurrent protective devices will operate as intended. The specific requirements for grounding and bonding are detailed in Article 250 of the NEC, which provides comprehensive guidance on how to properly ground and bond electrical systems to ensure safety. Article 250 covers a wide range of topics related to grounding and bonding, including the types of grounding systems permitted, the methods for grounding equipment, and the requirements for bonding metal enclosures and other conductive parts. It also addresses the grounding of specific types of equipment, such as generators, transformers, and separately derived systems. By following the requirements of Article 250, electrical installers and designers can ensure that electrical systems are properly grounded and bonded, reducing the risk of electrical shock and fire. Furthermore, the NEC addresses the requirements for identifying grounded conductors in Article 200. Section 200.6 specifies the use of continuous white or gray insulation for grounded conductors size 6 American wire gauge or smaller, and the use of white or gray marking for grounded conductors larger than 6 American wire gauge. Section 200.7 prohibits the use of white or gray wire for ungrounded conductors except under specific circumstances. Section 200.9 requires that grounded conductors be identified at each termination. These requirements help to ensure that grounded conductors are easily identifiable and that they are not inadvertently used as ungrounded conductors. In addition to the grounding and identification of conductors, the NEC also addresses the requirements for overcurrent protection in Article 240. Article 240 requires that overcurrent protective devices be installed in each ungrounded conductor to protect against overloads and short circuits. The size of the overcurrent protective device must be coordinated with the ampacity of the conductor it protects. Overcurrent protective devices must also be readily accessible and properly labeled. These requirements help to prevent overloads and short circuits from causing damage to electrical equipment or creating a fire hazard. The NEC also includes requirements for wiring methods in Chapter 3. This chapter covers a wide range of wiring methods, including rigid metal conduit, electrical metallic tubing, flexible metal conduit, non-metallic conduit, cable trays, and various types of cables. Each wiring method has specific requirements for installation, support, and protection. The NEC also specifies the types of conductors that are permitted for use in each wiring method. By following the requirements of Chapter 3, electrical installers can ensure that wiring systems are installed in a safe and reliable manner. The coordination of grounding, conductor identification, overcurrent protection, and wiring methods is essential for ensuring the safety and reliability of electrical systems. A failure to properly coordinate these elements can lead to a variety of hazards, including electrical shock, fire, and equipment damage. Therefore, it is important for electrical installers and designers to have a thorough understanding of the requirements of the National Electrical Code and to follow these requirements carefully. The NEC is updated every 3 years to reflect changes in technology, industry practices, and safety standards. It is important for electrical professionals to stay up to date on the latest edition of the NEC and to be aware of any changes that may affect their work. Many jurisdictions adopt the NEC as law, making compliance with its requirements mandatory. Failure to comply with the NEC can result in fines, penalties, and even criminal charges. To summarize, the statement that premises wiring must not be electrically connected to a supply system unless the supply system contains, for any grounded neutral conductor of the interior, a corresponding conductor that is ungrounded is true. This principle is rooted in the fundamental safety requirements for electrical systems as outlined in the National Electrical Code. By adhering to these requirements, electrical installers and designers can help to ensure that electrical systems are installed and operated in a safe and reliable manner, protecting people and property from electrical hazards. Understanding the roles of grounded and ungrounded conductors, proper grounding techniques, overcurrent protection, and conductor identification are crucial elements in achieving electrical safety.